Hello class, sorry I am out today. Today we're going to be talking about dot products of vectors. A dot product is really just kind of a way of multiplying vectors. And dot products can be found by examining your two vectors. So here we have vector v and then we have vector w. And when we calculate a vector, or when we calculate a dot product of two vectors, we are simply multiplying my x values together, then multiplying the y values together, signified by b and d, and then finding the sum. So, if you would like that in words, you multiply x's, then you multiply y's, and then you find the sum. Yes, the process really is that simple. It is important to note that whenever you are finding a dot product, you're actually getting a scalar value. You are not getting a vector. When you multiply a vector by a scalar, you get another vector. But when you do a dot product, you're just getting a plain number. So here's a quick example. Find the dot product of u and v if u is 3, 6, and v is 4, -2. So I always find it helpful to write it out. So to find my dot product, I'm going to calculate the product of the x's. So 3 times -4. And then the product of the y's, which would be 6 multiplied by 2. And so I have 3 times -4, which is -12. And then I have 6 times 2, which is +12. And -12 plus +12 is 0. So the dot product, u dot v, which is a lot of times what it's called, is 0. The dot product can be any number. It can be a positive or a negative. It could also be a fraction or a decimal. It just depends on what numbers you have. Now, this leads us to a very interesting point. When the dot product is 0, you have an orthogonal pair of vectors. Orthogonal is just a fancy way of saying perpendicular. So the vectors above would be orthogonal, meaning their sum is 0. The next thing, and the last thing I want to talk about, is finding the angle between two vectors. The angle between two vectors can be found by using the following formula. It involves a dot product. The cosine of theta equals v dot product with w, where v and w are just vectors, and divided by the magnitude of v times the magnitude of w. So, the example here, in fact, we have the angle between the vectors of u, 6, 2, and v, -4, 3. So the first thing we have to do is kind of find these each individual parts. First, we're going to find a dot product, so v dot w, which is the product of the x's, so 6 times -4 plus 2 times 3 for my y's. Then I have to find magnitude. And again, magnitude is just Pythagorean theorem. If you wanted, you could draw pictures of each one of these. But remember, your x component would be like your a, and your y component would be your b. So the magnitude of v is just going to be the square root of 6 squared plus 2. 6 squared is 36, and 2 squared is 4. So 6 squared plus 2 squared is the square root of 40. If you wished, you could go through and reduce your radical, but honestly, for this situation, it's not necessary because you're going to end up putting this in your calculator to find the cosine, or to find the inverse cosine. Oh, this is a vector. Sorry, these are vectors u and w, excuse me. Let's adjust this. Or u and v. This is actually vector u that we just found here. Now let's do vector v. It is important to note that just in general with dot products, the order in which you multiply your vectors, you dot product your vectors, doesn't make a difference. So kind of keep that in mind as you are doing these dot products. The dot product of u and v is the same as if you said v dot u. And our magnitude of vector v, since it's 3, 4, if you're doing Pythagorean theorem, it would make 5. So now we follow our formula. We have the cosine of theta equals u dot v. So that's this, which is 6 times negative 4 plus 6, which we have negative 18. Over u dot v, or sorry, u dot v over our magnitude. So we have 40 times 5, sorry, the square root of 40 times 5. And you can just punch this in your calculator. Remember, to get theta by itself, you're going to do the inverse cosine. So we have negative 18 over 5 root 40. And punch that in, making sure you're doing the inverse cosine. Again, a lot of times when we're dealing with vectors, we want to use degrees, so make sure your calculator is in degree mode. And a word of warning, whenever you are doing this with your calculator, you want to make sure that you are punching this in correctly. Depending on the version of your calculator, it might not be sophisticated enough to realize that you want both 5 and root 40 in the bottom of your calculator when you're punching it in. So you might want to be careful and put 5 root 40 in your calculator under or in parentheses, just to be safe. This angle between these two vectors is 124.7 degrees after you punch it in. And that is actually all we are going to talk about today. On Monday, we'll probably talk about vector projections and some more word problems.